this is part of an OSEP training program, and the training program is part of a center called the National Center on Leadership in Intensive Interventions.
And Martha, you actually have an NCLII scholar, is that true?
I actually do, yeah. Yeah, so I know something about the...
Okay. So this is about trying to prepare, a next generation in intensive intervention. And there are many ways of thinking about intensive intervention. And the one that I think the center has emphasized is data-based instruction or data-based intervention, or data-based individualization. Anyway, DBI. And it makes, as you know, it makes strong use of progress monitoring data to inform instruction. So instructors become really good at, looking at their data, determining whether what they've been doing works. If not, they make changes, they continue to collect data, and they go through that iterative process, hopefully eventuating in student progress. But there are other ways of thinking about intensive intervention. And one of them is not necessarily at the individual level, but maybe at the small group level, to look at relationships between what a group of students are like as learners and what instruction might match their strengths and weaknesses, although there wouldn't necessarily be a formal strength and weakness kind of, exploration or documentation. So some people referred to this years ago as aptitude by treatment interaction. And they were pilloried by behaviorists who felt like, the literature, the scientific knowledge did not permit such an approach. And now we're in a different place, and I think there's a renewed interest in, if not, quote unquote, aptitude by treatment interaction, moderator effects, mediator-moderator effects, to better understand whether and how a given intervention differentially affects different kinds of kids with different salient characteristics. But there's still resistance to that. And so to simplify, we're thinking, and for purposes of this discussion, we might simplify a little bit in talking about a nomothetic approach to instruction and an idiopathic approach. And there are lots of people, lots of behaviorist types who still adhere to good instruction is good instruction. What's good for one is good for all, nomothetic. And there are others who, take a different view. So the first question we have for you is whether you think of yourself as an idiopath or a nomothite.
You're not going to let me sit on the fence about this one, are you?
No, it's either or. No, you can take it anywhere you want.
Yeah.
Yeah. Well, I tend to be, I think, a little more nomothetic in the sense that I think there's only so many ways you can carve up human cognition. So there's only so many ways to get a reading problem, and only so many ways to get a math problem. So it's not infinite. And I think that some of the sort of underlying causal factors, there may not be that many underlying causal factors for these disabilities. And so from that perspective, I guess I'm a bit of a nomophite. But, I mean, as you know, in terms of my research, I do think that these treatment by aptitude interactions are interesting. There are some for math. There aren't so many of them for reading, but sometimes I wonder if we're looking in the right places for reading. You know, maybe we need to be looking more at comprehension, and most of the studies have been, I think, more to do with decoding. So maybe not surprising there. So I do think I think there's only so many ways that we can carve the human cognitive system to get good development of a skill and get poor development of a skill. But I think we can take those ways, you know, if there's maybe 3, I'm just making this up for math, and use those in terms of interventions or thinking about interventions. So I guess I am a bit of a fence sitter, but it comes from a perspective from cognitive psychology, which is that you have a system like the human brain, and it's kind of set up to do a certain number of things, and you know, there's not, it's not infinite. There's not 20 different ways to read or 20 different ways to do math, you know. So
well, just speaking hypothetically or conceptually, I mean, what if you were to throw into the mix affect and motivation, non-cognitive considerations, which I think historically supporters of aptitude by treatment interactions have considered conceptually.
Mm-hmm. Yeah, so I think there's an interesting intersection there because, well, there's I think 2 things that are important to think about. One is that, you know, we tend to think about learning and performance as being the same sort of thing and drawing on the same resources, but I'm not sure that we actually know that. And so it may be that some of the other sort of emotional attributes or cognitive attributes are more important for performance than they are for learning, or vice versa. But it's also, I think, the case that there are interactions that go on with, you know, cognitively between something like affect and a neurocognitive system like working memory, for example. So we know that anxiety really, you know, at the neural level and the behavioral level, anxiety, for example, has a negative effect on attention and working memory. So I think that there are these interactions that are in play that we haven't really done as much basic research looking at those interactions and what they mean for both children's learning and performance in general. And then, you know, are the interactions or are the patterns similar or different for kids who are having a really hard time learning?
Okay. A second question asks, has your research changed the way you think about the students that are of interest to you, that you study? And we're thinking here of the idea, this comes from Urie Bronfenbrenner, you know, the well-known child developmentalist, that the best way to understand something is to try to change it. And so, you know, what have you tried to change? And have you learned anything about the children you've tried to change?
Mm-hmm. So I'll use an example of a preschool, pre-kindergarten intervention, intensive intervention that we did with 4-year-olds who came into preschool with very low knowledge, and those kids are really low math knowledge, and those kids are at really high risk for later learning disabilities in math. And we took the approach of trying to, well, we know that attention difficulties are part of the cognitive makeup of these kids who are coming in who have also really low math skills. And so we took an approach to say, well, you know, what if we tried to improve their attention abilities and their math abilities at the same time with interventions in both attention and math. And I guess, to me, it's sort of an unfinished story because what I think I concluded at the end of it is that we don't know enough about what intensity looks like for these non-academic interventions. So if you're training working memory or you're training attention, I think we just, you know, the field is not mature enough for us to be able to say, or there's not data there to say, look, if I'm going to do an intensive intervention and I want to improve attention, you know, by sort of half a standard deviation in 4-year-olds, I need to do it for this long, and this is the kind of programming I need to do, and this is the kind of attention I need to address. And so I think that there's just, you know, there are lots of things that we don't know about cognitive training. In that sense, I think skill-specific training in reading and math are a lot farther ahead. You know, people have been doing it for longer, and they're more, they've done some of the parametric work to say, you know, what does this need to look like in terms of scope and sequence, dosage, that sort of thing. And for these other kinds of interventions that work on core cognitive abilities, we really don't have those data yet to help us to design sort of combined interventions, if you will. So I think that's a real shortcoming in the field, but I think it's an empirical question too. You know, if you can, so in our study, our attention intervention got small effects, but they were nothing to write home about. You know, they were very small. And so so the question I have is, can you really expect any kind of, to the extent that there might be transfer from improving attention and then, you know, having a child whose attention is improved, actually being able to take in more of the skill-specific training in math, for example. You know, to the extent that I have only improved attention a very little bit, you know, I've really minimized my potential chances for seeing transfer to something like math learning, if transfer like that exists. So, so to me, it's, you know, it's still an open question. Is what are the parameters that you need to manipulate? So you asked about experiment. You know, you really talking about Bronfenbrenner. You try to change something, and then, you know, in an experiment, see what the effect is. But what we found is that our intervention didn't change it enough, or to the point where we actually have any confidence that we have an answer to the question of whether or not training attention actually helps mathematical learning. So lots of open questions. But I want to go back, Doug, to something you said about, you know, I think skepticism about these aptitude by treatment interactions. There's a lot of skepticism also, which I think is related to cognitive training and whether or not it has any kind of, whether or not it will help kids who have learning disabilities. And I think, I mean, I have no idea. None of us, I think, have any idea. And what I hope, though, doesn't happen is that we sort of close off. I hope what doesn't happen is that people say, well, this isn't going to work anyways because the first several studies in the area are not showing very much. Because I don't actually think that we've done the work, the basic work that needs to be done to say yay or nay or maybe. So I hope that that kind of enterprise doesn't get shut down, in the first 5 years after it started up.
Well, and also because, as you well know, the basic paradigm for cognitive training is what we refer to as a domain general approach, and whereby, the assumption is that, there's this muscle that we can exercise with domain general tasks, that is, tasks that don't speak specifically to any particular academic domain. And if we do the training well enough, hard enough, the children's performance will improve across domains. But there's another way of thinking about it, and it's, domain-specific training. That really the way to see it, the way for the cognitive processes to train cognitive processes is in connection with particular domains and skills. And that's hardly been explored at all. So, I mean, to walk away from cognitive training when, as you say, we've just begun to really get into it, doesn't make sense. In addition, and underscoring what would be a very unfortunate turning away, I think, is that, and this goes back to Bronfenbrenner and sort of like trying to change and understanding as you try to change. As you well know, for the past 15 years, 20, 30 teams of researchers across the country have tried to change for the better students' academic performance in reading and math at quote-unquote Tier 2 with more intensive instruction. And much of that instruction has been more or less reflective of little d, little I direct instruction approaches, explicit, systematic direct instruction. And when researchers do that, they tend to do that well. We know how to do that. And a lot of kids respond who otherwise wouldn't. That's the good news. But the other important news is that there are always some decent number of kids, proportion of kids in all of our samples who don't respond. And so what do we do with those kids? So cognitive training may or may not be the answer, but I think what the trying to change and better understanding the kids we're trying to change, what that got us after 15 years was a very strong realization of the limitations of direct instructional approaches.
Yeah. I think there's really two quite interesting points to think about with respect to what you've said. One is that when you talk about cognitive training and thinking of it, making it more domain specific. So maybe using, if you're doing math and you're trying to train attention using math materials. I think part of the reason why, or one potential reason why we're not getting sort of some initial traction with some of the cognitive training work is that we haven't paid much attention to what we know about how these abilities develop to begin with. So, infants do not develop attention skills by sitting in front of a computer going through some kind of attention game. They actually, there's another developmental theorist, Greenough, who talks about experience-dependent and experience-expectant development, where there's an attentional and memory system that's sort of ready to go. It's probably already in progress in utero, but it needs to have environmental stimulation in order to grow and to change. And so, if that's the way these systems typically develop, then I think we need to start thinking about that in terms of the design of the interventions. And so that's where I think that domain-specific idea might actually play out in important ways or needs to be tested more. And then the other piece of it is, okay, so what if, and there are some people who think this and they could be right, what if these maybe after a certain age, so we don't even know, maybe there is some evidence to suggest that the effects for something like attention training are bigger if you are working with infants and toddlers than they are even by the time you get to 4 years of age. So, that could be important developmentally to think about interventions, about interventions for kids at high risk prior to being able to measure anything reading like or mathematical. But so we don't really know much about that. But the other part of this is, what if it doesn't matter? What if age doesn't matter? What if none of this matters in terms of what dosage you do for cognitive training, whether you use math or reading materials? What if none of that matters and you can't really change those, for want of a better word, those cognitive resources that kids bring to bear during learning and performance? And I think this gets to the heart of these treatment by aptitude interactions, where it then becomes a question of, for example, in Lynn Fuchs's work and Lee Swanson's work in math, thinking about, okay, so the kids with really low working memory are not doing so well with this component of the intervention, but if you tweak the intervention this way, then they do better. So I think, that's another way to think about these domain general cognitive processes and to design interventions that take into account kids' low working memory or low attention. But I think that's also in its infancy, because when I look at those studies, and I sort of put them all together at once, and I think, okay, so what is it that is going on here across these studies, if I sort of tried to do a mini synthesis in my head about when it's working better, when the math intervention is working better for kids who are low responders. What is it that these interventions that are working better for those kids, what do they have in common? And I'm not sure I know what it is. So I think, there is, though, value in a science, a part of our science, that actually experimentally manipulates what those things in math or reading interventions might be that that are going to be most helpful for kids with very low working memory, let's say, or very poor attention. But that, to me, is in its infancy, too. But I think we are getting some, not me, but other people are getting some traction there.
Well, I think that one of the ways to address the issue you just raised about, what parts of the instruction might, well, this isn't exactly what you said, so if I'm misstating or misrepresenting, let me know. But what I heard you say was something like, it's when we look across interventions conducted by various teams of researchers, those that are more successful, say, than others in achieving their objectives, it's hard to know, because it's hard to know what is the, my term, active ingredients in these interventions. And it could be that there are different active ingredients in different approaches toward the same objective. And what we need and what we don't have is component analysis. And that's not the only way of, I think, of identifying the quote-unquote active ingredients. But it's one way, and it's a very expensive, resource resource heavy way of trying to do that. And I don't know that we'll ever have, the kind of money as a field of educational researchers or psychological cognitive researchers to do this kind of work. Let me.
It's not clear to me, though, that these things need to be done within the context of, a full randomized control trial. So I think that
They do or they don't.
they don't. I don't think they do need to be done in that context. I think that's the way they've been done now, and I have a great deal of admiration for doing it that way, because it gives you a lot of power. But so on the positive side, it gives you a lot of power, but on the not so positive side, it's kind of hard to figure out what it is that is the active ingredient or ingredients. So, I think there is room in the field of special education to do smaller experimental studies to try to work these things out. And I'm not talking about, sort of typical design experiments here. I'm actually talking about real experiments where these things are manipulated. But, and that you'd have to be very thoughtful about how to do that. But I think one could do that kind of components analysis on a smaller scale.
That would be an interesting thing to try to demonstrate, I think, for someone like you to try to demonstrate.
Yeah, something I've thought of a lot to try to figure out what's going on and with these treatment by aptitude interactions, which I find really fascinating, but I don't understand them.
So let me ask you something off script. You in this little conversation, you've fairly consistently distinguished between learning and performance. And so an intervention like, say, trying to strengthen attention may affect learning and performance. I don't tend to make that distinction, but I think you may be more correct than me. Is it possible that a given intervention, like an intervention to strengthen attention, positively affects performance without affecting in the same way learning?
In terms of my training, I've always thought of them as being two sides of the same coin, learning and performance. But I'm not entirely convinced that that is the case. I don't know. I think it's an interesting question to ask. And I base it on some of the cognitive studies in the sort of adult cognitive literature in mathematics, for example, showing that are dual task studies, essentially where the person has to do math at the same time they're doing something else. And that certainly, what we know is that certainly affects performance. So, if your central executive of working memory is busy, it's really hard to do some kinds of math problems. And so those data have been taken, and so those are performance data. And those data have been taken to then make an inference about development, to say, well, it's probably the case that the central executive is also important for learning math. And there are some longitudinal studies suggesting that's the case. But I'm not as convinced, I'm not as convinced that learning and performance are exactly the same thing. And I also think about the old literature where they did try to do cognitive training, which was not in learning disabilities, it was in ADHD and in kids with brain injuries. And, it was never, in that literature, it was never about helping kids to learn. It was actually about helping kids to perform, because essentially their, poor attention skills were getting in the way of their performance. Now, probably their poor attention skills are also getting in their way of their learning. But it just makes me think that they may not be, the things that you need for learning and performance may not be exactly the same.
So Devin, I've lost my picture.
You've lost your picture of yourself?
My screen has gone black.
Oh, it's probably because you haven't touched it in a while, but I'm, it's sort of like the, sort of screensaver type thing. But I am able to see you, no problem. That hasn't changed. So I'll pause for a second.
All right, let me see if all right, here we go. Okay, I'm good. So, Marcia, not to spend too much more time because I'm mindful of time, but so you would not rule out the possibility that an intervention that gets satisfactory effects can get satisfactory effects in theory because it's affected a kid's capacity to perform rather than strengthening the kid's learning.
Possibly. I mean, I don't really know, but possibly.
How would you design a study to try to parse that? You've got 30 seconds.
Yeah, let me just do that right now. Yeah, I mean, I don't know, Doug. I really don't know. One thing I have been thinking of is, and this is not working memory or attention, but it's something else that comes from the cognitive field, which is, thinking about the principles of learning. And so we've known for a long time that things like distributed practice and interlead practice are better for laying down long-term representation than math practice, for example. But we don't really, people try to kind of build that into their interventions for kids with learning disabilities, but I don't see a lot of studies that explicitly manipulate those kinds of things. And so when I think about other ways to apply, so I'm not really answering your question about designing a study, am I? I'm going off on in another direction. But when I think about ways to sort of improve interventions using what we know about human learning and performance, I think that's why I was thinking of this about human learning and performance, is that there are these very strong principles out there, like the testing effect, distributed practice, interlead practice, self-explanation, but we're not manipulating those in our studies with kids with these really these learning disabilities that are, where they're not getting very good improvement for some of these kids. So, I think there's people are kind of onto this. It's a hot topic, these, training these domain general abilities. But I think another area to think about from cognition is has less to do with the learner and more to do with the learning context and how that is set up. And have we really made as much use of what we know about how to lay down long-term representations as we could? So I'm sort of, I find one of the findings, and I think Lynn is an author on this paper, and it comes out of, I think it's Supakar and it comes out of Vinod Menon's lab, where they used a sort of math fact intervention. And what they found, and those kids weren't particularly low performing, but I think there is a newer study out with lower performing kids. But what they found is that measures of the hippocampus, which is the area of the brain that's responsible for laying down these long-term representations, that's what seemed to be important for learning. And that's a different memory system from working memory. And we don't talk about long-term representations and, laying down these long-term representations and hippocampal function when we talk about math learning. But I just wonder if we should, because those, the data from cognitive studies, long history of it on something like the testing effect and distributed practice, that's what those techniques are supposed to do, is help long-term retention and retrieval under a number of different contextual conditions. So, so I think there's other things to do at the intervention engineering end of things as well. So yes, we've had 15 years, of these intensive interventions, and they're not working for some kids. But do we need to think a little bit differently about what I think of as sort of the engineering principles in the intervention? So are there some things that we haven't really paid that much attention to that we should, that we know actually affect learning?
Okay, good. One last question. Can you identify one for us? Maybe, I'm sure you can do more than one, but can you describe one area that you think, an area of learning or instruction that is very important and that is understudied?
Well, this may be quite idiosyncratic, but again, if you look at the developmental literature, and there's some really nice longitudinal studies that are coming out in the last 3-4 years and continue to be published. And the role of language is really, I think, important. And, Elizabeth Spelke talked about this in 2005, where she said, you've got the human cognitive architecture for number, for, space, for this and that. But what coordinates all those things and what bootstraps all of those abilities and integrates them is language. So language is like your rocket fuel, it's your booster. And I think that the developmental data are actually are really falling in line with that idea. So if you look at longitudinal data now starting in infants, it's looking like language is pushing the development of executive functions. And then executive functions, might be pushing something in math or reading comprehension, let's say. But language, I think, is really important. And but it's another one of those areas that people are finding it's really difficult to move. But I think that
You mean to improve, to strengthen?
Yeah, that's right. But I think that language interventions, in terms of the way that we might think about them, they're in their infancy as well. But I think that is an area that I find personally intriguing, and in terms of thinking about cascading effects on executive functions, academic skills in reading and math. And I don't think we're doing as much as we maybe ought to be doing in that area. And that could really be ramped up to see, are there ways to really change language? See, that would be a nice experiment, right? Because longitudinal studies are great. They're better than sort of concurrent correlational studies because they have time precedence built into them. One thing develops before another, but they're not experimental. But I think the next question, based on these longitudinal studies, is to say, can we manipulate language? And if we do that, is there a cascade of effects on these other really important skills for children's academic development? So I think I think that would be a interesting area of research or something that needs more work.